Okay, in an effort to try to make the videos shorter, I went ahead and drew the three tables. So continue with piecewise functions. This is specifically going to be step functions. So when we're graphing step functions, it may be easier to do your three tables for however many pieces you have. So we have three pieces here. But as you get used to this, I think the step functions would be easier to do without the tables. But the first time, we're going to use the table as an example. All right, now number one, we're going to use this top piece. So we're saying that all of my outputs, all of my y values are going to be -2. So it's almost easy because I can just go ahead and fill -2, -2, -2 in. And I don't even know what my inputs are yet. I don't know what my x values are. Now remember, if our x is less than -3, so meaning this is my starting point, this -3, that's going to be my first point here. And because it's less than and not less than or equal to, I'm going to just give myself a note here that when I go and plot -3, -2, I'm going to use an open circle. So when x is -3, even though I know it can't be equal to -3, but it can get right up next to it, which is why I'm using an open circle, I'm going to have my output of my y value as -2. So -3, -2. Now, what are two more numbers that are less than -3? Well, as I move left on the number line, I would see -4 and -5. Now you can pick any numbers. You could say -8, -13 if that's your favorite number, but in terms of plotting these on the coordinate plane, you want to pick numbers that are easier and going to fit. Now, what about this second piece? Second piece, same thing. All my y values are going to be 1, so that makes that a little bit easier. So in the second piece, notice how it's different though. I'm looking for all the x values in between -3 and +2. Let's go ahead and write those down for all my x values. So I have -3 and I'm going to +2. So -2, -1, 0, 1, and 2. But how do we know if it's going to be open circle, closed circle? Remember, this goes on forever because we could have chosen many more numbers. Well, here, -3, we have the equal to symbol here. So we're going to use a closed circle to represent this -3 comma something. In our case, we know it's going to be 1. All of the outputs are going to be 1. Now, what about down here at 2? We're going to use an open circle for 2 when I go and plot this, 2, 1, because it is not equal to. So again, just my little note so that after I do all three tables, I don't have to look back at my piecewise function. I can look back at the notes that I created to make it easier to plot. Okay, I did that one a little fast. Let's take a look at number 3. So where's my starting point? My starting point is whatever x is either equal to or greater than or less than or equal to. And in this case, it's 2. So my x value is going to start at 2. I'm going to make a note that I'm going to use a closed circle when I go and plot that point because of the equal to sign. Now I need all numbers that are greater than this 2. Well, as I go to the right on my number line, I'm going to get numbers like 3, 4, and again, that goes on forever because I could have chosen 7 or 10 or 20. There's no restriction there. Where the second piece, we had a restriction. We started at -3 and we ended at +2. So we're looking at all the numbers in between that specific section. Okay, now what is the output? So whenever x is greater than or equal to 2, my output is going to be 3. So all of these are 3. All right, now finally, let's plot these pieces, and you'll see why we call it a step function. So number one, -3, -2, and I'm going to plot that with an open circle. So I'm going to go left 3, 1, 2, 3, down 2. I'm going to use an open circle. Just for the sake of the first one, I'm going to show you what is going to happen. But -4, -2. So I'm going to go left 4, down 2. I'm just going to put a point as a placeholder so I know the direction my line is going to go. And then -5, -2. And so another point is going to go here. And remember, we said that would go on forever. So this is going to be an arrow that goes on forever. Notice how it's a horizontal line. Hopefully your steps are horizontal and not slanted. If they are slanted, you should call somebody and get that fixed. Number 2, we are starting with -3, -1. And again, I'm using a closed circle for that endpoint. So left 3, 1, 2, 3, but I'm going up 1 and I'm using a closed circle because that's my starting point. Now let's take a look at the ending point. The ending point is going to be 2, 1, but it's going to be an open circle. So let's just plot that. So 2, 1, and I'm going to use an open circle. All of those other points are going to be connected in between. So negative 2, 1, negative 1, 1, right? We would negative 2, 1, there it is, there it is, there it is, 1, 1. So again, a horizontal line, but we have 2 endpoints. So again, looking more like a step or a staircase function. Let's go ahead and look at number 3. You should have an idea of what it's going to look like. We should get another step that's kind of around here. So we have a step, and a step. Let's go ahead and take a look at that. So at 2, 3, we're going to have a closed circle. So when I go right 2, up 3, we're going to have a closed circle. Let's go ahead and plot these other points. If you realize, hey, this goes forever, oh, that's going to be like this, except for it's going to go to the right forever. Yes, if you see that, you can just draw your arrow to the right forever and you're done. But if you don't see that right away, 3, 3, I'm just putting a point, 4, 3, oh, that's right. This would just go all the way to the right forever. So do you see step functions? We're going to have pieces here. Now you might be saying, why the heck do I care about what a step function is? Maybe you don't. But a real life example of a step function is if I asked you guys in class, hey, how many of you are 16? 5 people would raise their hand. Well, how many of you are 15? 8 people would raise their hand. How many of you are 17? 9 people would raise their hand. And I'd be like, you're all liars. You're all lying to me right now. Because you're not all exactly 17. You're not all exactly 15, right? You might be 15, 2 months and 4 days, or you might be 15, 7 months and 23 days. But you're still 15. We still say that we're 15. So what happens is I'm 15 years old from the start of my birthday. I'm 15 for 365 days until it gets back to my birthday, and then boom, I jump up and now I'm 16. And then I'm 16 that entire year for 365 days, and then boom, now I'm 17, right? And then I'm 17, and then boom, now I'm 18. And so we use our ages as step functions. In class, we're going to talk about more real-world examples of step functions. Popular examples are ticket prices. If you're under this age, you're going to pay $10. Once you get between these ages, you're going to pay $15. Once you get between these ages, now it's $20. And so a lot of times ages and money and theme parks are examples of step functions.